So in this video, I will introduce you two terms, which are the first one is the molecular formula and the second one is structure formula. And also in this video, you will learn how to give the IUPAC name for the homologue series members. So basically for the molecular formula, it is a chemical formula that shows the type and actual number of atoms of each element in a molecule. So basically for molecular formula, you will know the number of atoms for each element in a molecule. So say that for example, for the methane, the molecular formula for ethane is CH4. So here based on the molecular formula CH4 here, you know that there will be one carbon atom and at the same time there will be 4 hydrogen atoms. So here the molecular formula, based on the molecular formula, you will know the number of atoms for each element in a molecule. And here this is the electron arrangement in the methane, whereby for the carbon atom and the hydrogen atom, they will share one pair of electrons to form the single covalent bond. And then for the next one is the structure formula. So basically for the structure formula, it shows the type of bond, whether it is a single bond or it is a double bond, and how the atoms in a molecule are bonded to each other. For example, in the methane here, there will be a single covalent bond, whereby there is a pair or electron share between the carbon atom and also the hydrogen atom. So here the structure formula of methane here is CH4, whereby there is a single covalent bond that is between carbon atom and hydrogen atom, and one pair of electrons are shared between them. So next example will be the ethene here, whereby you can see ethene. The molecular formula will be C2H4. So based on the molecular formula, you can know the number of atoms, of each element in a molecule. So based on the molecular formula here, you know that for ethene, there are 2 carbon atoms, and at the same time, there will be 4 hydrogen atoms. And then here, this is the structure formula of the ethene, whereby you can see there is a carbon atom, and there is a double bond between the carbon atom. So next, you will learn how to give the IUPAC name for the homologue series members. So basically for the homologue series member, it can be divided into 2 components, which are the root name and also the suffix. So for the root name, you can know the number of carbon atoms, how many number of carbon atoms in a compound, and for the suffix, you will know what is the homologue series. So if you recall, I have explained in the previous video. So basically you will learn 6 homologue series. I repeat, which are the alkane, alkene, alkyne, alcohol, carboxylic acid, and the last one is ester. So here, the table 2.4 here summarizes the root name that is correspond or according to the number of carbon atoms. So say that when there is only 1 carbon atom, the root name will be METH, and then when there is 2 carbon atoms, the root name will be ETH, and when the number of carbon atoms is 3, the root name will be PROP, and so on out until 10 carbon atoms here, whereby the root name will become DEC here. And then next, the table 2.5 here shows the suffix of homologue series member, whereby we have 6 homologue series, and then for alkane, the suffix will be, so for alkane, the suffix will be ANE, for the alkene is ENE. So say that I have an example here, which is the methane. So for methane, the suffix here is ANE, indicate that the homologue series is alkane, and the methane METH here indicate there is only 1 carbon atom. And then for the alkene, say that I have one example here, which is the propene. So based on the suffix here, you will know that the homologue series will be alkene, and the PROP here indicate that there will be 3 carbon atoms in the alkene. Next, the alkyne, for alkyne, the suffix will be YNE, and then for alcohol, the suffix will be OL. So say that one example will be the butanol. So based on the suffix here, butanol or oil here, it means that the homologue series is alcohol. And then for the BUT here indicate that the alcohol has 4 carbon atoms. And then for carboxylic acid, the suffix will be OIC. So say that one example will be the pentanoic acid. So the suffix here is OIC, indicate that the homologue series is carboxylic acid, and PNT here indicate there is 5 carbon atoms in the carboxylic acid. And the last one is ester. So basically for the ester, the suffix is RITE, and I will explain more details regarding the ester in the coming video. So by now you have to know how to give the IUPAC name for the homologue series member. So basically they are they can be divided into the root name and the suffix. So these are very important, so you must really understand and memorize for the number of carbon atom, and that is correspond to the each of the root name. So here you will see the several examples here. So here I have the methane, I have the ethane, propane, and butane. So all of these are the alkane. Why? Because if you look at the suffix, it's end with ane, which means these are all the alkane. The homogeneous will be alkane. And for methane, the root name will be meth, so there is only one carbon atom. Ethane, there will be 2 carbon atoms. For propane, there will be 3 carbon atoms. And for the butane, the number of carbon atoms will be 4. And then next, I have ethene, propene, butene, and pentene. So these are all the alkene. Why? Because if you see the suffix will be E and E, it's end with E and E here, so the homogeneous will be alkene. So here for the ethene, the number of carbon atoms will be 2. For propene, the number of carbon atoms will be 3. Butene is 4. And then for pentene, the number of carbon atoms will be 5. And next, I have pentanol, hexanol, heptanol, and also octanol. So if you observe here, the suffix here is OL, so it means that the homogeneous series is alcohol. So here for the pentanol, the number of carbon atoms is 5. So for hexanol, the number of carbon atoms is 6. Heptanol is 7, and the octanol, the number of carbon atoms will be 8. So next, a few more examples here, which are the pentanol acid, hexanol acid, heptanol acid, and also the octanol acid. So since the suffix is end with OIC, so all of these are what we call it as the carboxylic acid. The homogeneous is carboxylic acid. And for pentanol acid, the root name is PNT, so it means that it has 5 carbon atoms. So for hexanol acid, they have 6 carbon atoms. Heptanol acid, it has 7 carbon atoms, and for the last one here, the octanol acid, they have 8 carbon atoms. So let's try a few more examples here. So in this case, you need to give the IUPAC name for each of the compound. So here for alkane, you have 3 carbon atoms. So we know that the root name for 3 carbon atoms will be PROP. So it will be, I will name it as propane. So the suffix will be end with ane for the homogeneous or alkane. And then for the alkene with 4 carbon atoms, since it has 4 carbon atoms, so the root name will be start with BUT, and then for alkene, I will name it as butene, since the suffix is E and E. And then for the question 3, for alcohol with 5 carbon atoms, so basically for 5 carbon atoms, the root name will be PENT. So alcohol, I will name it as a pentanol. So the suffix here, as you can see, is OL. And then for the last question here is the question 4, the carboxylic acid with 6 carbon atoms. So basically for 6 carbon atoms, the root name will be HES, and then for the carboxylic acid, the suffix will be end with OIC. So I'll name it hexanoic acid. So here, do yourself, there are several examples here that you can have a try. So you can write comment or answer in the comment section. I will give the feedback very soon. So that's all in this video. Thank you.